Okay. We're going to dig in. We'll revisit this. I just want to get a real quick vote. Now that you've had a chance to look at this data, if you agree with this claim, the claim is that since more of the crew survived, 212 crew members survived, and that's more than any of the other classes of passengers, that means crew members were more likely to survive. Raise your hand if you agree with this claim, and I'm going to get just a real quick count. I've got one. Anybody else agree with this claim? All right. Raise your hand if you disagree with this claim. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Raise your hand if you are undecided. Undecided. I should end up with everybody in the room counted. So far, I've only had 11 people counted here. If you are undecided, raise your hand. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's not everybody, but that's close to everybody. All right, so one person agrees with the claim, 10 people disagree, and we have 9 undecideds. I passed out a little sheet to you that's going to tell us how to read this kind of table. And I just kind of want to talk about these things. Take notes as you see fit. I will post like a very detailed set of notes on Canvas, but I don't want to take a bunch of notes today. Oh, that's wonderful. Hold on, let me get it working again. Oh, my Wi-Fi totally went out in second period today. Stop sharing. Start sharing. Here we go. All righty. So this is called a two-way table. In a two-way table, you are taking two different categorical variables. Do you remember when we talked about categorical variables? Yeah. Categorical variables, you're going to go around and people are going to be placed in groups based on their responses. In this case, Travis is considering running away and joining the circus, so he surveyed 20 of his friends to determine the most popular career options. So here are the different careers. That is one variable. What do you think the other variable is that he's looking at?
Boys and girls.
Boys and girls. So over here on this side of the table, this is another variable. He's looking at gender.
Variable, can I think of it as a base?
Can you think of it as a what?
A case.
A base?
A case.
A case. Good question. Cases aren't the same thing as variables. Variables are the categories that your cases would be placed in. In this case, for our categorical variable. So,
what is it on top of variable?
it says other variable.
Oh, okay.
So we have one variable across the top and the other variable. This is always going to have two categorical variables. But KT, your question leads me to another good question here. If career is a variable and gender is a variable, what are the cases here? What are the cases?
The friends.
The friends, the 20 friends that Travis surveyed. So we've got 20 cases here. We have categorical variables, which remember is not a measurement. But we're going to use this table to record information about each of these cases. It's going to record the information for both variables. We're going to end up with numbers inside here, but that doesn't make it a quantitative variable. The numbers in here tell me how many people fit those categories. Does that make sense? Choosing clown or acrobat is not a measurement about a person, but once I get my groups made, I could say, oh, there's 5 people that want to be clowns. There's 7 people that want to be acrobats. There's 10 people that want to be elephant trainers. I can count them once they're placed into groups, and that's what's going to go in my table here. So every case or individual has recorded data for each of these variables. There are different types of information that we can get from our table. Just to fill this one in here. Do you guys see up here where it says he talked to 13 boys and 7 girls?
Yeah.
So boys, the total number of boys is going to go right here. So this is where I would put the 13. That's all the boys. 7 girls, where would I put that?
Total.
Yep, total girls. How many friends did he talk to? 20. If I add the 13 and the 7 together, I get that 20, right? We're going to fill in the rest of this table as we move along. I don't have any other information here that would let me fill this in. But we would have information about how many boys picked clown, how many boys picked acrobat. That's what you would need to finish filling this in. So things that we can find with our two-way table. One of them is called joint relative frequency. I'm just going to call this joint frequency. This is a ratio. What does a ratio mean? 1 to 1, 2 to 2. Ratio means I can write it as a fraction. This is a ratio in a particular category and the total. And I'm going to call this the grand total. The things up here on my screen, the cells that are purple, on your page it has joint frequency written in. If the numerator comes from one of those boxes, it is a joint frequency. It's called joint because we are joining a row and a column to get that number.
What number? The total?
Whatever number goes in that box. There will be a number when we're analyzing these. Just like that Titanic table, you know how it was all filled in with numbers?
You're talking about the bottom, like where it says totals?
Nope, right here. If the number comes from any of the boxes on mine that are purple. So we'll look at the Titanic one called joint because we are joining a row and a column. So an example of joint frequency. I'm going to write a ratio. Maybe I want to know how many boys chose clown. And I want that proportion. So it would be how many boys chose clown over my grand total. And we'll practice writing some of these. That's my joint. Marginal frequency. These numbers, the numerator, would come from one of the margins. That's actually exactly why they call it marginal frequency. So it's what's in green here. Okay, do you have a pass or something for early release? No? Okay, all right. You'll want to watch the video for what you missed, okay? Marginal frequency is, again, a ratio. So what does ratio mean we're going to write again? A fraction. Of the sum. What does sum mean to do? Add. The sum of one category. So that is one row or one column. And the grand total. So an example of something that would be marginal frequency is all the people that want to be a clown over my grand total. Or it might be all the girls over the grand total. I'm going to look at all of one row or all of one column. I'm going to add up all those numbers until I get to the total, and then I put it over my big grand total. All right. That's two of the ratios that we can find with this. There's one more. It's on the back side, and then we're actually going to practice with this, and then we'll go back and revisit that Titanic idea, okay? Because now we have a better understanding about how to look at and read a table. All right. So on the back side, the last one that we need to talk about is called conditional frequency or conditional probability. This is a ratio. So again, a fraction. Of one joint frequency one joint frequency. Joint frequency, again, would be the little boxes on the inside. And the related marginal frequency. The marginal frequency would be the total of a row or column. So practically, what does that mean? It means all the numbers from my fraction would come from a single row or a single column. So if I wanted to know the percent of people, hold on, I'm going to rephrase it, percent of girls. Because I wrote down the wrong thing. My brain and my eyes weren't connecting. Percent of girls who chose elephant trainer. If this is what I wanted to find out, all the numbers that I'd be looking at would have to come from right here. Because I don't care about the boys at all. I just want to know the percent of girls. So I totally ignore this, and I would totally ignore this. None of the numbers would come from anywhere but that girls row. If I wanted to know percent of girls who chose elephant trainer, then I would have number of girls who chose elephant trainer. But now it's not going to be over the grand total. Since all my numbers have to come from here, it would be the total of the girls row. So that would be over total girls, not the grand total. I don't like how I wrote elephant, even though it's a long word and I didn't want to write it all out. All right. I want to practice actually finding some things. So if you look down at the bottom, the table's been filled in for us. How many boys?
13.
13. How many girls?
7.
For a grand total of 20. Those are the first three questions. How many people participated in the survey? 20. That's coming from right down here. Here's my grand total. You said boys was 13, right?
Yeah.
13. Here's all the boys. And total girls? 7. How many people want to be a clown? 5 people want to be a clown. An acrobat? 6. An elephant trainer? 9. All right. Thank you. He actually just left to go. He went down.
Okay, thank you.
Thank you. All right. These bottom 3 questions, this is really what we use these tables for. Yes, Lee? Yes. All right. So first question here, how many boys want to be clowns? Where would I find that information at? Close. Boys that want to be clowns? What color are you getting that number from?
Purple.
Purple. That would be a joint right there because I've joined boy and clown together. So there are 3 boys that want to be clowns. What proportion of the sample would that be? Proportion means to write what?
Ratio.
A ratio, a fraction.
So is it 3 out of 13?
Yes, almost.
3 to 20?
3 out of 20.
Because that's the grand total.
Yes. How many boys want to be clowns? 3 out of 20. What proportion of the people surveyed want to be acrobats?
6. Wait.
Yeah, proportion want to be acrobats. We had 6 people that want to be acrobats out of my grand total, which is 20. This bottom one is kind of tricky. My denominator will not be a 20 here.
8 of 13.
Tell me how. Tell me why.
Instead of boys.
What proportion of people who selected, what did they select?
Elephant.
Elephant trainer. We know they selected elephant trainer. Or sorry, elephant tamer. I keep writing trainer. Whatever. All right. I know that I'm only looking at the people that chose elephant tamer. So am I looking at one row or one column? One column. All the numbers need to come out of here. How many people total chose elephant tamer? 9 people total, so that's my denominator.
So then we're doing it out of boys, though.
How many of those 9 people were boys?
Oh.
8. So this is boy elephant tamers. And the bottom is all elephant tamers.
Wouldn't it be 8 out of 20?
Good question.
Because it's only talking about boys, so I'm confused.
It's not only talking about boys here. It says what proportion of people who selected elephant tamer. So that means if I have the people around the room and I'm like,
Why didn't it just say girls and boys? Is that the trick the line to make somebody think?
it's not supposed to be tricky. Sometimes I just want to know, like, have you ever heard, like, there's not enough girls in STEM careers? Why is that? Of STEM careers. Science, technology, engineering, and mathematics. They keep trying to figure out how to get more girls in these.
Because man wrote that.
Not necessarily. Yes, sir. Yes, you may go to the restroom. So a lot of times we want to know, like, what percent of this group is made up of what have you. In this case, they want to know what percent of all the people that say, when I grow up and run away to the circus, I want to be an elephant tamer, what percent of those people are boys? That's what this question is asking me to find. So I want to go back, keep this in front of you so you have it to reference. I want to go back and look at the Titanic thing again. Yes, absolutely. You're welcome. All right, so I'm back on page 43. What was the claim again? Yeah. The claim is that the crew was most likely to survive. That's the claim that's being made. And we didn't really have a way to evaluate whether that claim was true or not. So they're looking at each class of passenger. So if I just look at the first class passengers, so I'm only looking right here. If I want to figure out the percent of people that were first class that survived on this ship, this is one of those conditional relative frequencies. How many of these people survived? 203 out of how many first class passengers? 325. Grab your calculators real quick and divide that for me. Yeah, it's like a 0.62, right? So that would be 62%. If you were a first class passenger, that's what your ticket said, you had a 62% chance of surviving on the Titanic. What about for our second class passengers? How would I figure out how likely they were to survive? 118. Why am I dividing by 285 and not 325 or 2201? That's the total amount of our second class passengers. So if your ticket said second class, there were 285 people, 118 of them made it safely off the ship. If I divide that, what do I get?
41%.
Yeah, so like a 0.41? Yep, 41%. So stopping right here and looking at this, knowing what we know now about the Titanic and your chance of surviving, would you want to be a first-class passenger or a second-class passenger?
First class.
First class, greater chance of making it off the boat, right? What about my third class?
170. Oh, do you want to stop?
Mm-hmm.
Oh.
Survival rate of 25%.
Survival rate of 25%. Tell me how you came up with that.
178 divided by 706.
178 divided by 706. And you said that's 25%?
Yeah.
Yep. Anybody want to volunteer to be a third class passenger?
Yes.
I would definitely want to be first class.
Don't say that.
What about my crew?
I think 24% survival rate.
Tell me what I'm dividing to figure that out.
200. Oh my gosh, I have
212 divided by 885. There were more crew on the boat than any other single class, right? There were a lot of people working on this boat to make sure that the passengers were comfortable. 212 of them made it off the boat, but a lot of them did not make it off the boat. You said it was 24%?
Yeah.
So what do you guys think about this claim that the crew was the most likely to survive?
Yeah, they go.
Were they more likely than the first, second, or third class passengers to make it? No, this claim is false. The crew was most likely to not make it.
They dead. Next time I get on the boat, I'll be first class.
Right? There were big changes made after the Titanic sank because of safety. It didn't used to be the rule that there had to be space for every single person on a lifeboat if the boat went down. Now that's a requirement. There has to be room in a lifeboat for every single person that's on a boat. One of the other things, and I don't know if anybody in here has ever been on a cruise before, but if you go on a cruise, the very first thing they make you do that first night is practice an evacuation drill, just like a fire drill at school. But they want to make sure that if something happens, you know where to go, you know what to do, so that this doesn't happen again. So how is it that some people could claim that the crew members were the most likely to survive? Like, how are they coming up with that?
They probably thought that to survive, they have the most numbers.
Yeah.
They have the most out of the other three classes.
They're just looking at the raw numbers. They're not looking at how many total there was of each group. If there were only like 300 crew members on board, then that would make sense. 200 out of the 300 people survived. Yeah, that's not bad. But 200 out of almost 900, that's not so great anymore. All right, turn the page. We're going to do one more thing with a two-way table today. So now we're on page 44. I need some information from you guys as a group. So first one should be pretty easy. Left-handed. Can I have everybody that is left-handed raise their hand for me? If you are a lefty. 1, 2, 3, 4, 5. We've got 6, 7 people that are left-handed. Awesome. Left-handed, 7. If you're not left-handed, I'm assuming you're right-handed, correct? Oh, you're both? Okay, so don't raise your hand for this one if you're both. Right-handed. Raise your hand if you're right-handed. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. I got somebody not counted. Sorry, I missed you. All right. I miscounted. It's 7 and 18. 7 and 18. How many people are in the room today? 25. All right. For this other one, we're going to figure out, just like you have a hand dominance, you have eye dominance. For real. We're going to test it, and we're going to find out whether your left eye or your right eye is dominant. And we're going to record that information right here. Okay, so here's how you do it, and there's directions for it right up here. To check your eye dominance, you're going to create a triangle with both hands, all right? You're going to find a small object that you can put in the middle of the triangle. Like, I'm going to put the turtle inside my triangle, okay? With both eyes open, I'm going to put that object in the center of my triangle. And then I'm going to close one of my eyes. For your dominant eye, the object will stay in the middle of your triangle. For your non-dominant eye, it's going to move out of the middle of your triangle.
My dominant eye is
Why
wrong.
is it?
I know we were.
All right. Do you guys understand how to do it? All right. You find some object. You put it in the middle when both your eyes are open. Close one. If it stays put, that's your dominant eye. All right. Here's what I need. Of the 7 people that said they were left hand dominant, so my 7 people that raised their hand for left, raise your hand again if your left eye is dominant. 1, 2. All right. I just want to make sure that I'm getting a correct count. Those of you, my 7 people that said they were left hand dominant, raise your hand if your right eye is the one that's dominant. So left-handed, but right eye. You think both your eyes are dominant? All right. Only 2 people were really confident that it was left hand and left eye. How many people should be saying right eye dominant that are my left-handed? 5. How do you know? Yeah, 7 total left-handers. 2 said left eye. My right-handers, the 18 people that raised their hand because they said, I'm right-handed. If your left eye was dominant, so you write with your right hand, but your left eye was dominant, raise your hand for me. 1, 2, 3, 4. Right hand, left eye. 1, 2, 3, 4, 5, 6. 6. So how many of my righties are also right eye dominant? 12.
Oh,
That's okay, because 6 and 12 together makes all of those 18 people, right?
yeah.
So in our room right now, how many people have left eye dominance? 8. Right eye dominance? 17. Beautiful. All right.
Fantastic.
I want to describe any relationships that we see here. What are some things that we can use this information to say? What kinds of interesting things could I say about the people in this class just using this two-way table? Could we talk about the proportion of people that are lefties?
Yes.
Okay, so percent of class that is left-handed. You guys have room on the lines down below. I don't really have any lines to write on here.
Oh, well.
My apologies. My lines are way off the screen down at the bottom. How would I write the proportion for the percent of class that's left-handed? 7 out of 25. Can somebody divide that on their calculators for me?
You said it's what?
7 out of 25. 0.28, so about 28%.
20.
Yep. So without setting up another proportion, could you tell me what percent of the class is right-handed? What'd you say? 72. How did we get 72?
Wait, what?
What percent are right-handed? Yep. 100 minus 28%. Because 100% would be everybody in here, right? 100 minus 28%, or we can do 18 over 25. We should get 72%. What percent of my left hand dominant are also left eye dominant?
Wait, say that again.
What percent of left-handed are also left eye dominant? I heard 2. Does the 2 go on the top or the bottom? Top. What goes on the bottom?
7.
7. Why?
28%.
Yeah, I said percent of left-handed people, so I knew I was only looking right here. Can somebody divide that for me?
What are we dividing?
I rounded it.
2 divided by 7. You said 28?
Yeah, I got
29, I rounded it.
29%? Yeah.
Oh.
That's okay. 28%, 29%. I'm not going to fuss over a percent. Last thing I need to talk to you guys about. For something like this, there's a special notation that sometimes gets used that I want to make sure you're familiar with. So I'm going to erase some of this so that I have room for it. So you might see a big P for probability. Left eye, and then a line and left hand. This row or column is all I look at. All right. When you see notation like that, it means the same thing. I want you guys to practice a little bit with a two-way table tonight. You've got some homework where you're given a table and you're going to try to write some of these proportions or these ratios. Okay? We'll practice a little bit more with two-way tables tomorrow and see what kinds of information we can get from them. I hope you guys have a fantastic rest of your day.
You too.
Thank you.